whether or not the goal state has been attained. So it is a state to represent whether the goal has been reached or not. Tree and graphs are example for non-linear data structures, and in a tree, all the elements we represent in the form of nodes. Additional information required for this particular goal. Those informations are missing or they don't have those type of information, or we say domain information. Welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. We are going to discuss about search algorithm terminology and as well as types of search algorithms. See, these are the topics to be covered in this session. Let us start with the definition of search algorithm. Now we know what is algorithm. Algorithm is a step-by-step procedure to solve a problem which are textual in nature. So, see, what is search algorithm? See, this search algorithm in artificial intelligence. It provides solution to many artificial intelligence related issues. So, searching algorithm is one of the component in artificial intelligence. So, this is search algorithms. In the next slide, we will see what are all different terminologies or different terms which are related to artificial intelligence. Now, first one is search. So, searching solves a search issue in a given space step by step. So, this is one step is to solve a problem. So, it is going to solve a problem step by step. So, that is a definition of what is a search, or that is the intention of search. Now, under that there are terms like state space. See, what is the state space? A search space is a collection of potential solutions a system may have. As all of you know that, you might have studied in our previous session about different types of searching or algorithms or agents. So here, under that, it is possible to store, or it will be having a collection of potential solutions in a system in order to reach the goal. See, that is the definition of state space, means already existing solutions to a problem. Next one is start state. What is the meaning of start state here? It is a space where the agent starts the search. The agent is a component of AI. It has to search for a particular solution. So it has to start from the agent, start the search. So that is the state called start state. Next one is goal state. So what is the definition of goal state? It is a function that returns the current state and returns whether or not the goal state has been attained. So it is a state to represent whether the goal has been reached or not. See, these are the different technical terms. Next one is search tree. See, what is a search tree here? So a search tree is a tree representation of a search issue, and the node at the root of the search tree corresponding to the initial condition. You know what is a tree here? Tree is a data structure. So tree is a non-linear data structure. Tree and graphs are example for non-linear data structures, and in a tree, all the elements we represent in the form of nodes. So that is the meaning of here, the node at the root of the search tree correspond initial condition, means in other words we can say the search start from the root, or root is the first node of the tree. This is a data structure, non-linear data structure. The next term is actions. What is the meaning of actions? It describes all the steps, activities or operations accessible to the agents. Here, as all of you know at this stage, agent is very important part of AI. So everything, all actions are taken through AI agents. So it describes the steps, activities, operations accessible to the agent. Next one is transition model. So it is a description of what each action does. So here in these actions, we are going to list out number of actions to a particular solution. So here we are going to define each and every actions available in the agent. Next one is path cost. It is a function that gives cost to the each path. So here for every path it is going to give a numerical value that is nothing but your path cost. Next one is solution. What is a solution? The action sequence connects the start node to the target node. So what is a solution? It is a step-by-step procedure to solve a problem or to reach a goal. So from start till the target node, the steps involving are nothing but solution to the particular problem. Next one is optimal solution. So what is optimal solution? If a solution has the lowest cost among all the solutions, it is said to be optimal solution. So what is the optimal solution? Here every solution will be having its own the path cost, what you have seen in this point here. So it is nothing but the integer value given to each and every path in the search operation. So based on that, so optimal solution is nothing but which has the lower cost among all the solutions available in the agent. So these are all different terminology we are using in artificial intelligence or in search algorithm. In the next slide, we will see the properties of search algorithms. In other words, we can say what are all the components, the four important properties, nothing but the components or the factors or criteria we are using in search algorithm. So first one is completeness. First one is completeness. What is completeness? It is a search algorithm is said to be complete if it guarantees to yield a solution for any random input if at least one solution exists. So what is the meaning of completeness? We can say any algorithm is complete. It based on the result or the solution of this. So your solution must work for random input values and it should provide solution to different types of input or random inputs. Then we say it is the algorithm is complete or is completeness. Second factor is optimality or optimal. A solution discovered for an algorithm is optimal if it is assumed to be the best solution, lowest path cost among all the other solutions. So as we know that, so AI agent will be having number of solutions or predefined models. So based on that, we have to select the best solution. How can we say that which is the best solution? Based on the lowest path cost, what we have seen on the previous slide. So each and every path will be provided a value, there's a numerical value. Based on that, we are going to decide the best or solution, and that would be the optimal or not. Next one is time complexity. So what is the definition of this? It measures how long an algorithm takes to complete its job. The time, it depends on the time, how long an action will be completed, that the time taken by any action to complete, that is the meaning of time complexity. Next one is space complexity, when the maximum storage space required during the search as determined by the problem's complexity. So here the maximum amount of space it should be available for a particular action to be executed or to be completed. So this is space complexity. So these are all the different factors or important points to be considered while you are working with search algorithms. In the next slide, we will see what are different types of search algorithms. So here basically there are two types. One is uninformed, second one is informed. So under uninformed search algorithm, we have different types. One is breadth first search, uniform cost search, depth first search, depth limited search, iterative deepening depth first search, and bidirectional search. These are all different algorithms under uninformed search. Now in informed search, here The breadth first search is the one. Second one, A star search. See, these are all the two types under informed search. So these are all different types of search algorithm in AI. In the next slide, we will see uninformed or blind search. Let us see the factors or the definitions of uninformed or blind search. The first one is it does not include additional information. Say, what is the meaning of this? Say, any problem to be solved, so we have to provide data or input. That is, the AI agent, it perceives the input from the environment. So here, what is the meaning of other information? So here they have information which is defined in the problem definition. So these uninformed search will be having information about the information given in the problem definition. You know what a problem definition? See, one of that is the first method in problem solving over computers. So what are the information given in the problem definition? It will be having information. Apart from that, it may not gather additional information. It may be required for reaching the goal, or it may have to use other additional information in solving a problem. Next one is they don't have domain information such as location and the goal. Say this algorithm doesn't have the location or the where the goal is, or what are the different additional information required for this particular goal. Those informations are missing, or they don't have those type of information, or we say domain information. Next one is it only contains information on traversing the tree and identifying leaf and goal nodes. So the meaning is it is have information about traversing the tree. So what is the meaning of traversing? Traversing is a type of operations in the data structure where all the elements are to be visited at least once, or with respect to tree, all the nodes, maybe a leaf node or a goal node, has to be visited at least once. So it has information only for traversing, means is visiting or going to all the nodes. Next one is uninformed search is a method of searching a search tree without the knowledge of the search space, such as initial state, operators, and test of the objectives. See, uninformed search, it is a one type of method. They don't have other information or knowledge of other objectives or state of other paths. It is also known as blind search. Another name is blind search, and it goes through each node until it reaches the target node. See, that is nothing but traversing. So in this algorithm, it traversing through the tree until it reaches the target node or goal node. Next point is which has a high cost. What we are talking about high cost, what you have seen in the previous slide, each and every path will be having a cost value. There is a numerical number, it is an integer number. So based on that, we have to decide the cost. So this uninformed search, it is of high cost. Then BFS and DFS are different, or example for uninformed blind search. This is breadth first search and depth first search are the examples for uninformed blind search. In the next slide, we will see the definitions of informed search or heuristic search. Now here, informed search algorithm in AI use domain knowledge. See, this point was missing in the previous uninformed search. So domain knowledge, in the sense it will be having the location and the goal and additional information which may required during algorithm or during searching operation. So it is a smart search which include additional information to reach the goal. That's what I have told you in the beginning. Now they are more efficient and with the lower cost. So this is the lower cost. Next, heuristic search is another name of this search. So another name of informed search is heuristic search. Next point is it is not always guaranteed to find the best solution. but it is guaranteed to find the decent solution in a reasonable amount of time. See, that is what you're talking about, time complexity. So here, this informed search algorithm, it may not guarantee a solution, but is going to provide a solution within the time limit or within the reasonable amount of time. It used to solve many complex problems that would be impossible to handle otherwise. Means it is possible to use the same algorithm for different applications, and those applications which cannot be done by using other different types of algorithms. Dear students, so far we have discussed about different terminologies used in search algorithms and different types of search, and we have learned the definition of uninformed search and informed search. We will continue our discussion in my next session. Thank you very much.